All right, welcome back, students. We're going to now see some more examples of how we can model with quadratic equations. Now we're going to look at a problem. Example 3, NASA can create a weightless environment by flying a plane in parabolic paths. The table shows the height in h in feet of a plane t seconds after starting the flight path. Passengers experience weightlessness, a weightless environment above 30,800 feet. Write and solve an equation to approximate the period of weightlessness. All right, so before we can approximate the period of weightlessness, we need that equation to do so. Now notice we don't know the exact location of the vertex this time. All we have are a grouping of points. So what I'm going to use is I'm going to use our equation ax squared plus bx plus c, the standard equation, to find our equation. And we're going to use values from here. So I'm going to input, what if x is a 10? Then what is the height? So 10 squared would be 100a. And then if x is 10, then that's 10b plus c should be equal, and the height was 26,900 at that level. All right, so now let's do it with 15. Or actually, I kind of like round numbers. Let's use the 20 instead. So let's do 20 squared would be 400a plus 20b plus c is equal to 3,600. All right, and once again, let's use nice round numbers. So we'll jump to the 30. 30 squared is going to be the 900a plus 30b plus c is equal to 32,100. All right, so we have our three equations ready for us to solve, and I'm going to be using elimination. I'm going to use my first equation to eliminate the b in the second equation, and I'm going to use my first equation to eliminate, well, actually, let's just do the c's. C's are going to be nice and easy. But yeah, I'm going to use the first to eliminate the c in the second and the c in the third. All right, so let's get started with that process. So first, let's write down our second equation. 400a plus 20b plus c is equal to 3,600. And I'm going to subtract my first equation. So that'll become minus 100a minus the 10b minus the c and minus the 26,900. Okay, so then we'll just be left with 300a plus 10b, no c, and about 3,700. Okay. So this is one to remember. So now I've got one equation with only two variables. Now I'm going to use my first equation and my third equation. So now we'll do the 900a plus 30b plus c is equal to 32,100 minus the first equation. So 100a. Needed to be minus again. So minus 10b minus c minus 26,900. So that'll be 800 All right, 800A plus 20B is equal to 5,200. All right, now I've got my second equation with only two variables. Now I'm going to use those two together, eliminate one of the variables so that we can then get only one variable and solve for that. So I'm going to put this equation down here on top. So my 800A plus 20B is equal to 5,200. And I'm going to subtract 2 times this equation. So I'm going to multiply all of this equation by a negative 2. So that'll be negative 600A minus 20B minus, let's see, times by negative 2, 6. Is that right? 3,700 times by negative 2. Yeah. Okay, so that's going to give us just a 200A is equal to negative 2,200. So A, therefore, equals negative 11. Okay, now that we've got our A, we can substitute in our A into either of these equations in blue to figure out B. So substituting in a negative 11 in for A, we can then solve for B and get that B is equal to 700. Now, once we know A and B, we could take any of these equations. I'd probably use the top one. Put in those values for A, put in the values for B, then solve for C, and that'll give us 21. I figured the solving had gone on long enough, but hopefully I showed and demonstrated kind of the harder part in all of that is breaking them down bit by bit using elimination until you're only solving for one variable. Once you got one, everything can be smooth after that. All right, so my equation must therefore be, let's see, A is 11, so y equals negative 11 x squared plus b 700x plus c 21,000. Fantastic. All right, we've got this equation, and now we can answer the question about the approximate period of weightlessness. So there's my answer. Now notice that passengers experience a weightless environment above 30,800 feet. So we want to know at what times are they above 30,800 feet. Okay, so essentially, I want to know when y is at 3,800. Now I'm going to put this in standard form so that we can then use the quadratic formula. So minusing 30,800 from both sides of this equation, and I will get 0 is equal to negative 11 x squared plus 700x minus 9,800. So now a our quadratic formula to solve for the values of x that make this true. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. What this is going to give us is two different values where x is equal to 20.8 or 42.8. Now, they are weightless in between those amounts. So notice the plane was rising up. It passed that threshold at 20.8 seconds and then went down past that threshold after 42.8 seconds. So that means they were weightless for 22 seconds. All right. Here we've got a situation. So this table shows the fuel efficiencies of a vehicle at different speeds. We want to write a function that models the data and use the model to approximate the optimal driving speed. So the problem right here, and I'll demonstrate it with our TI calculator. In the previous example, they told us the information was parabolic. They haven't let us know that it's parabolic, so we need to verify that this is actually parabolic. So I've already put all this data into the list by doing stat, edit, there. They're in the list. Let's make sure to turn on a stat plot. So second stat plot, enter, turn it on. Got my scatter plot set, and I'm going to zoom in on just the stats. Okay, so great. That looks parabolic, but only roughly. It's not exact. So if we were to try and find the second differences of these, we would find that we are not getting and in fact, it would be hard to find the second differences because our miles per hour were not given consistent intervals. So it's hard to know exactly. So in this situation in which the numbers might not be exact, what we're going to use is a regression. So we're going to use our calculator to figure out what this equation should be. Now, one thing that's nice is if all the points do perfectly match up, you could even use this method rather than doing all of this solving. You could use this method with your calculator to find the equation even faster. All right, so let's look at what this method of finding the equation with a calculator is. I've already got all my data put into my lists. Now, from my main screen, I'm going to do stats, calculate a quadratic regression. My X list was in 1, my Y list was in list 2, and calculate. All right, so it's letting me know what the value of A is, what the value of B is, and what the value of C is. I'm also going to go ahead and turn on diagnostics because I want to see one other thing. So calculate, we'll go through this again. I want this R squared. So what this is telling me is that I was right. These didn't line up perfectly, but they do line up closely. Now I'm going to use this information to go ahead and write down what my equation should be. So the equation y equals, let's see, the a was about a negative 0.014 x squared plus 1.37x minus 7.1. All right, so there's our equation. They want us to use this model to find the optimal driving speed. Okay, so if this is a table of miles per gallon, we want the maximum amount of miles per gallon. So let's figure out what the maximum amount would be. Looking at our graph, we can see that there would be a maximum amount somewhere. Maybe in between these two, but not quite clear exactly what it is. So let's use our equation that we were given. So a negative, oops, need to make sure that's a minus. Down here is where we do negatives, 0.014. X to the power of 2 plus 1.37x plus, or sorry, minus 7.1. All right, so let's graph it. All right, that looks like a pretty good match. Now, I want to have the calculator help me figure out where that max is. So I'm going to go to second trace, or in other words, calculate. Come over here to maximum, press enter on that. Notice it's saying down here left bound, so I want to go to the left of where the max is and press enter. Now it says right bound, so I want to go to the right side of where the max is. All right, I'm definitely to the right of it and press enter. And it says guess. So it says guess because it's not going to give you an exact answer, but it's going to give you a pretty close one. So this one is saying that at x equals 48. So the miles per gallon would be 26.4, and your speed that you would be driving would be 48.9. So in other words, at about 49 miles per hour. So 49 miles per hour is the optimal driving speed. All right, hope this helps.